Hi everybody, at the end of this video I want to be able to generate text-to-speech locally on my machine and also maybe call it programmatically such that when I write a program, it speaks to me. So let's see how we can get software to speak to us and tell us computational results, print out statements, and all of that stuff. The first step is obviously to find some text-to-speech engine, something that we can trigger text-to-speech with locally. Let's have a look at GitHub. I already found one, but maybe I'll change my mind. What is this Piper TTS? That sounds fun. Nope. That's a bit too unpopular. I found one that is called Piper. And it's this one right here. And it has 9.7k stars. So I find that sounds quite promising. The project has moved to this repository here, and let's see what we can find here. And all we have to do is pip install Piper text-to-speech, and let's just do that. I will create a new directory in my projects directory, and I will call that text-to-speech. Let's cd into that, and let's do pip install Piper TTS and see what happens. Could not find a version that satisfies the requirement. Piper phonomizer. Oh, great. Okay, so there seems to be already some dependency issue. Okay, I think we're healed. Are we healed? And then let's do Python 3.11 and create a virtual environment. Python 3.11 does not exist. Why? Ah, it's 3.13. Okay, that exists. Then let's do Python 3.13 and let's create a virtual environment for Python 3.13. And then inside that virtual environment, we can for sure install Piper TTS. And it seems to finally do something. Oh my god. Please work this time. But this looks quite healthy. So at least there's no versioning conflict or versioning error. There's no condition that is being broken by the Python version. That's very good already. It seems that our library is installed. And looking at the output of pip list, we can see that we have Piper TTS installed right here. That's already very, very good. Okay. Now we can probably use this Python API here. And we've already installed it. Then we can download a voice, and then we can use that voice in Python. So let me just copy that voice, and then let's play around with that. And no, I don't want to use Python 3, I want to use Python 3.13. That's important. Okay, maybe it was already downloaded, that was quite fast. Or did I break anything? At least the output says that it's downloaded. And then we can create a script where we import wave and we import from Piper, import Piper voice. And then we load a voice and then we write a wave file. Okay, let's see if that works. I think I can remove the Python repositories. can I not? Permission denied. There's no permission denied. I think I mistakenly installed everything into that subdirectory here. So maybe let's again do pip install Piper TTS here. That doesn't work. That's because I have to create a virtual environment using Python 3.13. And now inside this environment, I can do pip install Piper TTS. Why? Why doesn't it work? I have to activate the virtual environment, bin activate. And now I can do it. Yeah. All right, in the meantime, we can go to that directory where our text-to-speech project resides, text cd into text-to-speech. We can create a script.py, or let's call it tts.py, and let's paste all that code. And here we load a voice that we downloaded before, but where is it located? I don't know. I mean, we downloaded it here. So where is it located? Let me just try to download it again and see if the file resides in the current directory. I have to activate the virtual environment here as well. Okay, let's download the voice. Maybe not using Python 3.8, but 3.13. And here it says the voice is downloaded, and there's an ONNX file. What is an ONNX file? ONNX file. Okay. ONNX is an open format built to represent machine learning models. Aha. Okay, so this is not just a voice. This is basically a neural network that we downloaded. Cool, that's nice to know. And what is the JSON file? Okay, the JSON file apparently contains metadata about that neural network. Or it is configuration, I can't tell. No, okay, this specifies the language that is being used. This is metadata. Okay. Then let's open the text-to-speech Python file and load the voice, the neural network, from the current directory. And let's see if that can execute. 3.13 and then tts.py. This doesn't work. Why? ONNX runtime. Protobuf parsing failed. Maybe I accidentally interrupted the download of the neural network, so let me just remove both of those files and try to download it again. And let's see if it's really just 34 megabytes. Maybe it's a bigger file. I can imagine that it's way bigger. Okay, it's downloaded. And it's 61 megabytes. So I interrupted the download, and when I tried to re-download the file using the newer Python version, then it just assumed the file is already present and didn't attempt to download it again. So let's execute the script and see what happens. Okay, it didn't print anything out, so that is a very good sign. And there's a test wave file. How can we play a wave file in Ubuntu? Ubuntu play wave. You can do it with many command line tools. I suggest the play command to install it. Install socks. Okay, then let's install socks. And then we can just play the file. Let's play test wave and see if we can hear anything.
Welcome to the world of speech synthesis.
Nice. Okay, that is very good. Let's go to back to the file. There's the test that it prints out. Just let me open it here. This is now our file editor terminal. Okay. Currently it prints out, welcome to the world of speech synthesis. Can we make it print something else? Or can we make it say something else? Hello, I am happy. Hello, don't forget to like or dislike and leave a comment. I like to eat ramen noodles and I come from... No, I don't come from anywhere. I come from another galaxy. Let's see how that sounds like. And the best thing about that speech model is that it works completely offline. As you know, we don't use an internet connection, which makes this quite powerful because you just have to download the neural network and then you can play whatever you want to play. Okay, then let's execute the script and then play the wave file test.wave. And let's see what happens and how long it takes.
Hello, don't forget to like or dislike and leave a comment. I like to eat ramen noodles and I come from another galaxy.
That's so nice. Can we also, currently, the thing that's happening is I am executing the Python script and then I am playing the output file separately. Can we play directly from within Python? That would be interesting to know. So this library has a Python API, and okay. We can use streaming, which is playing the voice immediately as it is being generated. I don't know if my terminal can do that, however. I can just try to do it. Let's try to stream the voice. So we are still loading the voice here, the neural network, and then we're synthesizing some speech. Let me just enter some text. Hi, I am Daniel. And then as it is being synthesized, it returns chunks of speech. And those chunks are written raw to somewhere. But where are they written? This method, write raw data, must write the data somewhere, obviously. We can just see if this can execute right away. So let's do Python 3.13 and then let's do text to speech. Okay, and there's an issue with that command, and that is set audio format. Is it maybe possible that we have to implement those methods somewhere? This. Set audio format. Where is this method coming from? I don't know. Let's just pragmatically return to the last way of doing it, of generating the voice. And let's do the following thing. So we generate a voice like so.
Hello, don't forget to like or dislike, and leave a comment. I like to eat ramen noodles, and I come from another galaxy.
So a voice is being generated, the file is generated to your local memory, and then that file is played separately. We could also play that file somehow within the script by calling something within Python execute shell command, and you can use this subprocess library to execute shell commands locally. So let me just copy that and paste something here. And here you can go ahead and do subprocess run, and we do the following. We do play, and then we do test wave. And test wave is obviously the file name, so we can extract this in to a variable. That variable is called test wave. And then here we can use the file name, and here we can use the file name as well. Okay, and I would expect this piece of code now to load a neural network, to open to create a new wave file, to write synthesized speech to that wave file, and then immediately play the synthesized speech. Let's try. So I'm just calling the script. I call only the script and not the local play command. The script should play the sound itself. Let's try.
Hello, don't forget to like or dislike, and leave a comment.
Very
I like
good.
to eat ramen noodles, and I come from another galaxy.
Very, very good. Okay, so that works. So we can now immediately play sounds. So, oops. This is a, just for some context, this is a 1 hour timer. I try to spend 1 hour a day working on my videos, and you just heard that timer beeping, which indicated that 1 hour is now over. Yeah, so right now this video is going for 43 minutes, and before that I spent some time thinking of what I can record today, and that timer just went off, which means that I could now stop the video and continue recording tomorrow, or I could, yeah, you get the point. So this is just a focus timer for myself. It's a very good strategy in case you want to stay productive and stick to a certain habit. Just set a timer, 1 hour or 30 minutes, and then do that. And once the timer beeps, you can let go of the task or decide to continue. And obviously, because we're in such a good run, I decide to continue now. So we have this file name here. And let's try to Can we integrate this with an AI maybe? This would be cool. So I have this Ollama installed locally, and we could ask Ollama a question, or we could ask the script a question, feed it to Ollama, and then have the voice generate then have the voice library generate a spoken version of the answer. I'm thinking if that is even feasible. Okay, let me just try. I'm creating a new window. In this new window, I am using this pane down here to do Ollama list. Maybe Ollama run, which starts an Ollama AI server. Come on, Ollama list should actually list the models. Ollama serve, and this starts running Ollama. And now Ollama is running, and I should be able to do something like Ollama list here, which prints the models that I have installed, and I would like to use CodeLlama latest. So let's do Ollama run CodeLlama latest, and that should launch this local AI model, this local large language model on my machine. And then I would expect it to be able to somehow interface with it and just answer my questions. Let's just ask it a simple question. What is 1 plus 1? Very short answer, please. And possibly this AI model is quite stupid because it's just running on my local machine. So let's see. Oh no, it figured out the response. So it's able to say that it's 2. In which city does housing cost a lot? Very short answer, please. New York City. Okay, that's good. That's a good sign. So technically, if we can figure out how to... how can I exit this? If we can figure out how to feed a simple query to that AI model via command line or some API, then I can fetch the response and make the text-to-speech model speak the answer. Yes, and as the help already says, we can specify the prompt immediately. And of course, I did miss that. Ollama run, CodeLlama latest, and then let's feed it the prompt. And let's say, what is the longest month of the year? Short answer, please. Okay, so that seems to print the response also in some buffered way. I don't know if the text-to-speech model can handle that. What if we feed the output into a file? So let's do t output.text, and then let's read the output text, and there it is. Okay, that is good. So we can generate an output text via command line. Then going back to where's our Python code? There it is. Here we should be able to now do the following. We can do subprocess run, and then we say we want to run Ollama run and then the model name, Ollama latest. Of course, all those are arguments that we could specify or that we could hardcode or feed via arguments. These are variables that we could feed via arguments. This is just for the sake of demonstration, keeping things simple. Of course, all those things are already set up on my machine, and on your machine it might differ if you set up a different AI model, etc. But let's keep it simple. And then the last argument is the prompt. Prompt. Like this. And then the prompt that we feed this script is taken from an input argument. Python command line argument. Let's look at how to accept a command line argument in Python. We can use sysargv and then pick the first, the second, or the third argument. This would be the programmatic way of doing it. Of course, there are libraries responsible for parsing, accepting arguments. Yeah. Prompt. And prompt is wait. Okay. I was just checking whether prompt is written like this. No, which looks ridiculous now that I know the answer, or like this. Okay, and the prompt comes from sysargv, and then the first argument that is fed into the input. And we print out the prompt. Like so. After we print out the prompt after receiving it. And then we asking the AI. And here the subprocess is running and feeding. No, it's just running. How do we get the response from that subprocess? Python subprocess. Maybe let's find out how to use a pipe here. Using the subprocess. What does the subprocess return? It technically should return only an opcode, I think. Return. No idea. Python subprocess pipe to commands. We can use popen. Python subprocess or get standard out. That should also be okay. Check output. And we have to decode that output. Subprocess check output. Yeah, let's just try that. I mean, we're totally hacking together something that is something that not everybody would appreciate. Let's put it like this. Let's run Ollama, run code llama latest, and then the prompt. Then we close that, those arguments, then we decode that, and this should be the response string. And then we print the response string to the console. Received response. Just to confirm that this is correct. And let's just try to execute the script and see what happens. This doesn't work. We have to probably import sys. Sysargv doesn't work. Why does sysargv not work? Python command line argument. Import sys and we access sysargv. Which I am doing. Of course it doesn't work because we don't provide an argument. So we, let's just say hello. Our prompt is hello, and now it's asking the AI for an answer. And it seems like the AI is thinking. I'm wondering how that thinking turns out in the resulting speech. And now it's trying to speak. Okay, it doesn't.
Hello, don't forget to like or dislike, and leave a comment. I like to eat ramen noodles, and I come from another galaxy.
Of course, we still try to speak the old text that I hard-coded here. We have to speak out loud the response, of course. But there's already a problem I can see in the output here, that is can't encode 0-bit unknown or not applicable. So maybe the solution would be to... No, let's try out again. Let's just try out. Let's not think too much.
Hi.
Huh? Did it answer? Did it just take my hi? No. Let's try again.
It's great to connect with you. Is there something specific you would like to talk about or ask? I'm here to help with any questions you may have.
No, it's really working. It's working. It's working, guys. Okay, then let me do the following. Okay. Now, just to summarize what's happening here, we have coded a simple Python script that takes a prompt, feeds it to an AI, then generates a response, and then talks back to us. How nice is that? Okay, let me just ask something. What is the meaning of life? Short answer, please. 1 or 2 sentences. So now I'm asking it something, and then it's going to respond to us using text-to-speech. How awesome is that? And it's all done locally in the command line. of course, the AI is processing. And
The meaning of life is to find purpose, happiness, and fulfillment in one's own experiences, relationships, and interactions with others. It is a personal and individual quest for which there is no definitive answer, but rather a continuous journey of self-discovery and growth.
I'm so proud of this project. This is so simple, but yet hacker-like. We just hacked together those self-standing libraries and softwares, and now we have an AI that is speaking to us, and we assembled all of that ourselves. How awesome is that? Let me just ask one last question. Should viewers on YouTube subscribe to me? Short answer, please. And let's wait for the answer. And if you like this video, then please leave a like and subscribe. Don't forget to like. This is very important for the YouTube algorithm. And consider becoming a Patreon where I make all the code that we produce on this channel accessible to all of you in a private repository. Okay, let's hear the answer.
Yes, many viewers on YouTube will subscribe to you if they find your content valuable and engaging. Subscribing is a way for them to stay up to date with your latest videos and to show their support by regularly checking in with your channel. Additionally, subscribers may receive notifications about new videos, which can help keep them engaged with your content.
Okay, so the AI told you so. So let's stay connected, everybody. I hope you enjoyed this video. And see you next time. Bye-bye.